Let's continue on with the homework video guide. And for question number 9, we have a boat below which travels at 4.2 meters per second relative to the water, and the river is flowing at 2.8 meters per second. And for this problem, it's asking at what angle theta must the boat head to reach the destination directly across the river. Okay, so here's the destination across the river, and we're given a vector for the river, we're given a vector for the boat, and we want to find this angle right there. And we're also given this vertical line right there. So basically what we want to do is, based on these vectors that are given to us, we want to create a triangle here. In this case, it looks like a right angle triangle, and let's just see if we can set up a trig ratio to find that angle there. Okay, so let's go ahead and redraw the diagram right here using our vector. So here is the vector for the boat, and the boat had a speed of 4.2 meters per second. And then the river had a boat that was going in the right direction like that, and that had a speed of 2.8 meters per second. And then we can also just connect the triangles using this resultant vector like that. And our goal is to find this particular angle right there. Okay, so based on this right angle triangle that we created based on with the vectors here, let's go ahead and figure out what that angle has to be by using trig ratios. And since we're given the opposite right here, this is the opposite, and this right here is your hypotenuse, the trig ratio that connects the opposite and the hypotenuse is the sine ratio. So sine of the angle theta is equal to your opposite over your hypotenuse. So my opposite is 2.8. and my hypotenuse is 4.2, and we're just going to go to our calculator and figure out what that ratio is. So 2.8 divided by 4.2 is roughly 0.666 repeating, and then we have a sine of the angle here. And if we want to figure out what that angle has to be, we have to use the inverse sine. So that means theta would equal to the inverse of sine of 0.666 repeating. You want to put that into your calculator there, and roughly you're going to get around 42 degrees if I round up. So that's how you would find your angle for this particular question. So a very simple trig question to kind of get this homework video guide started. Let's move on to the next question now, question number 10. And for question number 10, it states that a few minutes after takeoff, a jet is heading due east. So due east is going in the right direction with an airspeed of 300 kilometers an hour. If the wind is blowing at 60 kilometers an hour towards 40 degrees south of east, what is the jet's ground speed? Okay, there's a few things that we're going to have to do for this particular problem. We have a vector here for this 300 kilometers per hour. And we also have another vector that's going at with a magnitude of 60 kilometers an hour, but it's heading at a direction of 40 degrees south of east. Now for the 40 degrees south of east, if I take a look at my northeast southwest diagram, 40 degrees south of east is really right here. This is 40 degrees. If that's 40 degrees, then this has to be 50 degrees to complete the 90-degree angle. And we also know that over here, this is going to be 90 degrees as well. So later on this problem, we're going to add the 90 and the 50 to get 140 degrees when we construct a triangle for this problem. Okay, so let's go ahead and construct a triangle for this problem here. We're going to start off with this 300 kilometers per hour vector that's going due east. Okay, so if I had to draw that, this is going to be a little bit of a big vector there, so that's going to be 300 kilometers an hour. Okay, that's going due east. All right, and then we have a wind that's blowing at 60 kilometers towards 40 degrees south of east. Okay, so if I'm going the southeast direction, that's going to be just like the red vector that we had above. All right, and as I stated, the 40 degrees is going to be right here, and what that means is this angle right here, based on this diagram right there, is going to be 140 degrees. So this will be 140 degrees right there. Okay, and then in order for us to complete this vector diagram, we're going to draw the resultant vector like that, connecting from head to tail. Okay, and what we need to do is, let me go ahead and just finish off labeling this diagram here. So we have the 300 kilometers per hour, and this is going to be 60 kilometers per hour. And what we need to find now is the jet's ground speed, which is the resultant vector. So we've got to find the magnitude of that green vector here. So let's go ahead and label this as just c. I want to find the value of c right there. So my vector right here isn't super straight. I'll try my best to correct that. And let's just see if we can find the magnitude of that vector c. Okay, so the formula that we're going to be using right now is the cosine law. So that's going to be denoted as c squared equals to a squared plus b squared minus 2 times a times b times cos of the angle. Okay, so we know the angle here in yellow is going to be 140 degrees. We know a and b, those are the values of your vectors of 360. And our goal is to find c, which is the resultant vector there. Okay, so if I go ahead and just insert the numbers into the cosine law here, this will be bracket 300 squared plus the 60 squared minus 2 times 300 times 60 times cos of the angle, and the angle here is 140 degrees. Okay, so from here on, it's really a lot of calculator work here. So c squared would equal to roughly, this would be 121,177.6. And if I take the square root of both numbers here, we'll get a c value. Our vector is roughly around 348.165 kilometers an hour. Okay, so if I had to just round up to the next if I had to round that up, that's roughly 350 kilometers an hour. Okay, so going back to the multiple choice options here, I guess option C would be the best choice there. Okay, let's move on to the next one here, question number 11. Let's move on to question number 11. And for question number 11, a pilot points an aircraft due east. Okay, so if I'm going due east, I'll use a red vector like that in the east direction. And at the same time, the wind is blowing from the south. Okay, so here is my wind vector blowing from the south. Because the wind is blowing from the south, there is a resultant velocity of the aircraft over the ground is now 64 meters per second, and that's going at 25 degrees north of east. So that is going to be displayed by this green vector, which is now 64 meters per second because of the wind vector. Okay, so based on my diagram here, I have 3 vectors, one in green, one in red, and one in blue, and we need to construct a right angle triangle and find the magnitude of the wind vector there. Okay, so let's go ahead and make a right angle triangle here. So the pilot was pointing the plane due east, and then we have a wind vector that's blowing from the south. And that gives us this resulting vector right here. So we connect the vectors from head to tail. And this has a value of 64 meters per second. And the resultant vector also has a direction of 25 degrees north of east right there. And let's just put a right angle box right there. And what we need to do is we need to find the magnitude of the blue vector, which represents the wind vector, right? So I will put an X there because I want to find the value of that vector right there. Okay, so if I use my angle here as a reference, this right here is your opposite, and my 64 is my hypotenuse. And the trig ratio that connects the opposite and hypotenuse sides of a triangle is the sine ratio. So sine of 25 degrees is equal to the opposite, which is x, and we divide that by 64. Okay, so there is my trig ratio there using sine of 25 degrees, which is my opposite over my hypotenuse. Okay, so since the 64 is on the denominator, you just multiply the sine 25 degrees by 64 to isolate for the x variable. So that's going to look like sine of 25 degrees in brackets, and we multiply that by 64. And that's going to equal to the value of x. Okay, and then from here we just go to our calculator and we should get ourselves an answer that's pretty close to, we should get 27.045. And if I just kind of round this would be roughly 27 meters per second. Okay, so that right there is the speed at which the wind blows, at 27 meters per second. Okay, so that concludes this part of the homework video guide.